Interaction overview diagrams. Interaction overview diagram is similar to the activity diagram, but in activity diagram we are defining a programming logic and business process. But it can also include other human interaction diagram as well as activities. They are intended to show control flow across a number of similar or simpler scenarios. The next one will be timing diagrams. It is essentially combine sequence and state diagram to describe an object various states over time and the message that alter the object states. The last one will be use case diagrams. It will capture the interaction between system and its environment. It also includes users and other systems. Next one will be notations in UML for architecture views. This we already covered in our third unit architecture views. We have our topic called notations in UML, right? So same here. So UML is a standard notation for documenting a software architecture. As we know already, right, there are three types of views based on our structures. The first one will be a model views, second one will be a component and connector views, third one will be allocation view. We can see one by one, right? First one will be model view. So we already know that it will be based on our code or implementation unit. It will have a classes, layers, decompositions, right? So we have a we can have some relations, that is aggregation, generalization is a part of relation, is as we already covered, right? So we have interfaces and relations based on that. So we already seen this example. We have a classes represented like this, packages, subsystems will be represented like this, and then classes with interfaces will be represented like this. Okay. So aggregation. Aggregation is nothing but one of the relations we are used to denote in a decomposition state. So decomposition is nothing but the one model is decomposed into one or two models. That is, we are divided the particular model into one or two. So then we can combine this particular model, right? So same way aggregation is nothing but a combine one or more modules, or we can cluster of modules that can become or being brought together. We can say it as aggregation. Okay. So here we are using it, the first part of diagram will represent the aggregation, second part will represent the decomposition. In aggregations we are representing within a packages we have one or more classes, that is we have a package called A. With that we have three classes B, C and D. This will represent that aggregations. So package A will get aggregated, that is combined one or more modules or cluster one or more modules, right? In a second diagram we have a A will have the main modules, which is decomposed into model B, model C and model D. Okay. So we are both, we can use here we are using a main packages, here we are using a classifiers. So next one is generalization. Generalization is one of the relations I used to represent for classes. So we have a generalization, you can represent as a generalization or specialization. So each and every thing will be represented in one general form. That we can solve it as a generalization. Here we are taking the shapes, that is polygon, circle, spin line will be the one of the simple shapes. These are brought into a general form called a shape. Okay. So this will be represented in a generalizations will be represented as a classes here. Each and every model, that is polygon will be one of the model, shape will be one of the model and circle will be one of the model. But here shape represents the generalization here. Dependency. Dependency will be represented in a layer approach. So there is we have no special notations to represent the layers. So for that we represent the particular layer in a packages. Okay. So to differentiate a package as under layer, we have giving a stereotype, that is before the package name we are giving a in a stereotype, that is we are giving it as a layer. So it will represent that the particular will be not the particular diagram will not represent a package. It will be layer A and layer B. So here layer A is dependent on layer B. So it will allow to use layer B can allow to use a layer A. So there is a dependency between A and B. So this will represent the dependency relationship in our model diagram. So model view. Next one is component and connector. So components are represented using a class construct. Okay, here interfaces will be we have an interfaces to our components. This we can call it as ports. Here we can represent in five ways. The first one will be no explicit represents. So we just represent in a one line. That is, we will not represent the interfaces explicitly. There will be implicit representation here. Okay. The second one will be using the interfaces using annotation. Using annotation, we represent our interfaces. The third option will be your classes or object attributes are used for interfaces. The third or fourth option will be UML interfaces are used for our interfaces. Here in UML interfaces, we are using one line with a circle with filled. Okay, this will can represent like a lollipop notation. We can say it is lollipop notations. It is used to represent the notation interfaces here. The fifth option will be interfaces as classes. So we can represent this with no explicit representation. We can give that is implicit representation for interfaces. Second will be annotation will be used as interfaces. Third one will be class or object attributes we can use as interfaces. Fourth, we can use UML interfaces as interfaces. Fifth, we can use classes as an interface. This will be represented here. Okay, so first option will be that is implicit representation, no explicit representation. So there will be only one single line is represented. The second option will be annotation. So we are giving annotation here. For particular here, we are giving an interface. We are giving annotation. For particular all we are giving annotation. So in interfaces representation annotation. Here we are using objects or class attributes. So we are using our attributes to represent the particular interfaces here. The fourth option will be using UML diagram. That is, we are saying that lollipop notation, right? So it's used to represent the interfaces. And then fifth option will be our classes. So we have a classes to one or more classes using one or more classes. Here also within the model we are using classes to represent our interfaces. So next one is connectors. So there are three reasonable options for representing connectors. Why? The first one will be connector types as association and connector instance as links. So here type will be we set as associations and the instance we can call it as links. The second option will be we can use this connector type as association classes we can use, and third will be connector types as classes and connector. Third type will be we are using as a classes and connector instance as objects. Okay. Last one will be allocation view. So allocation view already know we have we can see deployment diagrams here, and then we can communicate with the environment. Our work assignments will come under the allocation view, right? So in UML, a deployment diagram is a graph of nodes. We are presenting as a nodes connected by communication associations. We are connected here. Okay. So for that we are representing deployment view of UML. That is, we have a scheduler. For this we can meeting with database we have, and then this is the server, and then we have a client. So for these two we have a formal direct channel, and then we are representing a deployment diagram. So this will be represented as a deployment diagram here. Okay. So okay. Thank you all. I hope you all understand the topics well. If you have any doubts, please post your message in a Google Classroom. Thank you.